7th or 6th question number that I'm going to talk about. And these are the most often asked questions in the exam. So this is where we go ahead and we are given the root functions. We are going to do type of different domain functions, okay? So this is the first type of question where you're given a root function and you are asked to find the root of the domain of a root function. Now, one thing to keep in mind under the root functions is that whatever comes inside the root has to be strictly greater than or equal to 0. This is something that we have to ensure. We cannot find the root of a negative number. The second most important thing that we have to consider here is I should know how to find the solution of a root function, because that is something which I'm going to use many times. Now, one thing to find the solution of a root function is to use completing the square method, which I find very useful, by the way, a lot of times. Otherwise, the other most often method that we use is simply to find the value of x using this formula, minus b plus minus root b square minus 4ac by 2a. Now, this formula, I like to use this when I have to first ensure if there are any real roots which exist in the first place or not. And to check whether any real roots exist in the first place or not, I want to check whether in my equation b square minus 4ac is it greater than equal to 0 or not. Because see, if this is negative, what is coming inside the root, I will not be able to get any real value of this x. I won't be able to solve for the value of the x. Now, what are these ABCs? We know this. So my equation that I have at any point of time is y is equal to ax square plus bx plus c. So I know that this is the a that I'm talking about. This is the b that I'm talking about. And this is the c that I'm talking about. Now, to take an example of such questions, let us consider the mock question that was given in the exam. So in the test, the question that I gave you was x square minus 5x plus 6 under root plus 2x plus 8 minus x square under root. Now, one approach to go ahead and solve such questions is to go ahead and first find out the domain of functions individually. So why not just go ahead and solve this function separately and this function separately, and then go ahead and combine the roots of these functions. So for example, if I say x square minus 5x plus 6 is coming under the root, I know that this implies that x square minus 5x plus 6 has to be strictly greater than or equal to 0. If I use completing the square method, I know that this will be x square minus 6x plus x plus 6 greater than equal to 0. I am making use of a simple fact here that this has 1 into 6 is 6, and the factors of 6 can be 1 into 6, minus 1 into minus 6, 2 into 3, minus 2 into minus 3. All of this can give me my answer of 6. So, we can go ahead and use a simple fact like this. Now, here is the thing. If I look very closely at my equation, I have a minus 5 here. In order to get minus 5, I have rewritten this as minus 6 and 1. But does minus 6 into plus 1 give me a value of 6? The answer is no, right? So what happens in this case is, if I go ahead and use the method of completing the square, One thing that is clear to me is that under this scenario, I cannot use this method because when I open 6 and I write it like this, it is not solvable. I am not able to get the solution of the x in that case because I'm not able to kind of open this up and show it as a factor of the two things. This 5 when comes as a sum is not able to be shown as a factor of these two parameters. Now let's go ahead and in that case resort to our next method and find out what will be b square minus 4ac. So if I find out b square minus 4ac, I will get minus 5 whole square minus 4 into 1 into 6. So I will get 25 minus 24, which is 1. So one thing that is clear to me in that case is that because this is positive, at least I am getting a positive solution out of here. I'm able to solve this. Had this been negative, had b square minus 4ac been less than 0, then I would have stopped. I would have said it is not defined for any value of x. Because no solution of x would have gone ahead and solved this equation. So now I have made sure that at least there is some solution of x because, I understand b square minus 4ac is coming greater than 0. Now what I can go ahead and do is find the value of x using this method. So minus b plus minus root b square minus 4ac by 2a. So minus, what is my b in this equation? My b is minus 5. So minus of minus 5 plus minus root. What is b square? Minus 5 whole square minus 4. What is a? A is 1, c is 6. So 1, 6 upon 2. What is a? A is 1. So I get 1 here. So once I solve this equation, I get 5 plus minus root 1 by 2. So I get 5 plus 1 by 2. And I get 5 minus 1 by 2. So I get 6 by 2, which is 3. And I get 4 by 2, which is 2. Now, I just want to show you how you could have done using completing the square method. So if your equation is x square minus 5x plus 6, you could have written it as x square minus 2x minus 3x plus 6 because 6 has factors 2 into 3. You could have taken x common from here. You could have taken 3 common from here. And you could have got x minus 3, x minus 2. This was your completing the square method. So either way, you can go ahead and find the solution. Now understand, what am I saying? I am saying that whatever comes inside this has to be greater than or equal to 0. And this thing right here, I have found out 2 factors of this thing, and the factors are 3 and 2. So even if I go via this method and I get 2 factors 3 and 2, this means that that equation can be rewritten in the form of x minus 3, x minus 2. Or if I use completing the square method, then also I get that this equation can be rewritten as x minus 3, x minus 2. So I can use any method. But one thing that I have concluded from here is that I want x minus 3, x minus 2 to be strictly greater than equal to 0. Now, when is the product of two things positive? When both the things are positive or both the things are negative? When will be both of them positive? When x minus 3 is greater than 0 and x minus 2 is greater than equal to 0. This means x minus 3 has to be greater than, x has to be greater than equal to 3. This means x has to be greater than equal to 2. Both of them can be simultaneously satisfied only when x is greater than equal to 3. Because if I look at the number line 0, 1, 2, 3, this says x has to be greater than equal to 2. The other tells me x has to be greater than equal to 3. So this is the common area. So I get this as the answer. When will both of them be negative? When x minus 3 is less than equal to 0 and x minus 2 is also less than equal to 0. X is less than equal to 3 and x is less than equal to 2. So from here, what do I conclude? What is the common area? 0, minus 1, minus 2, 1, 2, 3. X has to be less than equal to 3 and x has to be less than equal to 2. So the common area that I have is x less than equal to 2. So I get two answers here. Either x has to be greater than equal to 3 or x has to be less than equal to 2. So the domain that I have got is that x can belong to anything from minus infinity to 2. 2 can be included because at 2 it is 0, or it can be anything from 3 to infinity. Please understand that this is the domain only for this equation. I've only taken this equation and I have found out the domain for this equation. Now, quickly take 5 minutes and try and solve the domain for this equation. Then I will solve it. So just try to solve the domain for this equation. Let's write down the equation. The equation that I have is 2x plus 8 minus x square. And because it is coming under root, to find the domain, I know that 2x plus 8 minus x square has to be greater than equal to 0. Only then I can solve something which is coming under the root. Only then it can be solved, if it is greater than equal to 0. So from here, just give me the domain of x. You can post your answers if you have been able to solve this. So let's just use completing the square methods again here. Alternatively, you can use the formula directly also. I'm fine with either of it. So if I use the formula to solve, that is also fine. Completing the square is also fine. But first of all, please understand what I'm going to do here. I'm going to take minus sign common. Okay, so let's see this and then I'll go back to the first equation again. So I'm going to take minus sign common and I'm going to get x square minus 2x minus 8 greater than equal to 0. Now please see what I'm doing. Very, very important. See, if I have a negative sign, if I have to shift the negative sign to the other side. For example, if I tell you 5 is greater than equal to 0, then I'm saying minus 5 is less than 0. Whenever I multiply negative sign in the equation, this sign right here, it changes. So if I have to bring this negative sign onto the other side, if I'm saying this is greater than or equal to 0, then this means that I'm also going ahead and saying that x square minus 2x minus 8 without the negative sign is less than 0. If I use completing the square methods on this, factors of 8 can be 4 into 4. 4 into 2, right? 8 into 1, 1 into 8, 2 into 4. So I'll use the factor of 8, this one, and I will say minus 4x plus 2x minus 8 less than 0. So I will say x minus 4 plus 2x minus 4 less than 0. I will say x plus 2x minus 4 less than 0. This is very similar to the equation that I had got earlier. I had got this equation from completing the square. Here also I'm getting an equation like that only. I've got one equation after completing the square. See? Now, let's see how to solve this. Okay. In order to find the domain of x, we are asking what are the values that I can put. Now, look carefully. If the product of two things has to be negative,